Hello students, in this session let us solve this question of columns. In this question we have to determine the crippling load for a T section of dimensions 10 by 10 by 2 cm and of length 5 meter when it is used as strut with both the ends hinged. Young's modulus of elasticity is given 2 by 10 power 5 Newton per millimeter square. So again, this is a question of column with T section. There is a crippling load we have to determine, and the dimensions are 10 centimeter by 10 centimeter by 2 centimeter. The length of the column is 5 meter, and the both ends are hinged. Pin joint is there. The modulus of elasticity of the material is 2 multiplied by 10 to the 5 Newton per millimeter square. So what will be the crippling load or Euler's load for this condition? Let us solve this problem. In this question, we are given with a T-section column, and this is a column which is at hinge joint. Both the points are hinge joint, and the length of the column is 5 meter. You know that for hinge joint, the column effective length is equal to the length of the column itself. So that's why we have written LE, effective length, equal to length of the column. Go to the theory lectures and check. We have proved that when the column is hinged at both the ends, then the effective length equal to the length of the column itself. And this is a T section and the dimensions are given to us, right? And we have to find out the safe load which can be applied on this T section column, right? And also E is given to us. Modulus of elasticity of the material is also given to us, 10 multiplied by 10 power 5 Newton per millimeter square. This is the modulus of elasticity of the material is given to us. We know that the safe load or crippling load of the material is given by pi square EI upon LE square. Some values are known to us. Effective length is known to us, that is 5 meter. E is known to us, given for this material. But what about I, moment of inertia? How to find out the moment of inertia? We have two axes basically, x-axis and y-axis, right? So there will be two moment of inertia, and you know that column fails in the direction in which the moment of inertia is minimum. So first of all, we have to find out the moment of inertia about both axes, x-axis and y-axis, passing through the centroid of the material. So let us assume that this is the centroid of this material G. Now y-axis will be passing through this centroid only because the half the T section is on this side and half the T section is on this side. So this is a symmetrical section about y-axis. So about y-axis, this is a symmetrical section and this is passing through this, right? So centroid of is this. If we divide this body into two parts, suppose this is one part and this is two part, the centroid of this is suppose G1 and centroid of this is suppose G2. So G1 and G2 will be lying on this axis, y-axis. So it is very easy to find out IYY when we obtain IYY. But this centroid, x-axis, is not passing through any of the centroid of this body. G1 and G2 not passing through G1 or G2. This is XX. So it is difficult to find out IXX. How we will find out IXX? First we will find the moment of inertia about this line passing through the centroid of body 1, and then we will apply the parallel axis theorem. We will take the distance, area multiplied by distance square. We will utilize the parallel axis theorem. Then we will take the moment of inertia of this body about its centroid, body 2, and then we will apply the parallel axis theorem, that A multiplied by this distance between two parallel lines square, and then we'll add up and then we will get the IXX, right? But first of all we have to find out this distance, where this centroid is lying. We don't know where this centroid is lying. So for that we will take a reference line. Say this is our reference line. This is our reference line about which all the distance will be measured. This is the reference line about which all the distance will be measured. And say the centroid of G2 is at y2 from this line, y2, And if the total length is 8 centimeter, then centroid will be lying at half the distance, that is 4 centimeter. So this will be 4 centimeter. Let us say this line, which is the centroid of the actual figure, this is lying at a distance y bar, which is unknown to us now, which we want to find out. And let us say the centroid of body 1 is lying at a distance of y1 from the reference axis, and this y1 is known to us, that is 8 centimeter plus 1, that is 9 centimeter. So y2 y1 is known to us, the centroid of the two bodies 1 and 2. We have divided this complete T section into two parts, 1 and 2, and the centroid of 2 is 4 centimeter from reference line, centroid of 1 is 9 centimeter from the reference line, and we have to find out y bar from the reference line. What is y bar? So we know the moment area method. We have taken the how to find out the centroid of a body using moment area method, taking the moments of the area, and y bar we know the formula, a1 y1 plus a2 y2 upon a1 plus a2. So from here y bar will be equal to a1. A1 is the area of this body, 20, 10 multiplied by 2 multiplied by y1, y1 is 9, plus a2, a2 is this body, 8 multiplied by 2 multiplied by y2, y2 is 4 centimeter, divided by a1 plus a2, 10 multiplied by 2 plus 8 multiplied by 2. So this will come out to be, solve it and you will get the value of y bar from this reference line, and this will come out to be 6.78. So after knowing y bar, the distance of centroid from the reference line, now we can find out Ixx, the moment of inertia about xx, because centroid is known to us, the distance of centroid from some reference line is known to us. So Ixx can be found out now. So what is Ixx? So that will be equal to the centroid of this body. Suppose we are taking first one, centroid of body 1, moment of inertia of the body 1 about centroid, plus area multiplied by distance square, right, between the parallel lines, parallel axis theorem, right. So this is the Ig1, centroid of body 1 in parallel to this line xx, parallel to xx, we are taking the line parallel to xx, plus area of body 1 multiplied by the distance, this distance Gg1. And what is Gg1? That is y1 minus y bar. So this is y1 minus y bar, y1 minus y bar square, distance square, distance between two parallel lines square, parallel axis theorem, plus Ig2, the moment of inertia of the body passing through the centroid of the body 2, plus area of body 2 multiplied by distance between two parallel lines, these parallel lines Ig2 and Ixx. This is Gg2, which is given by y bar minus y2, y bar minus y2. So this is y bar minus y2 square, like this, right. So this is the Ixx. Now put the values, all values are known to us, you will get the Ixx. So Ixx will be Ig1 is a BD cube by 12, centroid, moment of inertia passing through centroid, and this is perpendicular to 2 centimeters. This is now BD cube by 12. So this is 10 multiplied by 2 cube by 12 plus A1 BD, 10 multiplied by 2 multiplied by y1 minus y bar. Y1 is known to us 9, y bar we have find out 6.78 square. So this is this term, right, plus Ig2 BD cube by 12. B, what is B? B is 2 centimeter, D is 8 centimeter. 2 multiplied by 8 cube by 12 BD cube, 2 multiplied by 8 cube by 12, plus area is 2 multiplied by 8 multiplied by y bar minus y2. Y bar is known to us 6.78 from the reference line, minus y2 from the reference line is 4 square. Solve it and you will get the moment of inertia about xx. So Ixx will be equal to Use calculator, take your time and solve the question. You will get 314 centimeter to the power 4. So this is the moment of inertia about Ixx. Now we will find out Iyy. You can see here that YY section is already passing through the centroid of both the bodies, body 1 and body 2. So there is no need to use the parallel axis theorem because already passing through centroid. So Iyy will be equal to Ig1 plus Ig2, Ig1 plus Ig2 passing through the YY axis, right, in YY direction. Ig1 and Ig2 in Y direction. So this is now dB cube. So this is 2 10 cube. So it is 2 multiplied by 10 cube by 12 plus 8 multiplied by 2 cube by 12. So this will come out to be, solve it and you will get Iyy as 172. So this is Iyy. And out of these two, Iyy is less than Ixx. Iyy is less than Ixx. So we will use Iyy as our criteria for designing the calculation of load, right? So I minimum is basically Iyy, and that is equal to 172 centimeter to the power 4. Now the safe load now can be easily found out using a formula that pi square multiplied by E is given to us 2 into 10 to the power 5, 2 multiplied by 10 to the power 5 multiplied by 10 to the power 6 to make is Newton per meter square SI unit, multiplied by I is 172 multiplied by 10 power minus 8 to make it meter ki power 4 divided by effective length is same equal to 5 square. From this you will get the safe crippling load and the value will come out to be 136 kilonewton. 136 kilonewton. Solve it and you will get this value. So the answer of this question is basically 136 kilonewton, the safe crippling load. So this is the safe crippling load for this column which is hinged at both the ends and it is of T section, right? So first you have to check which moment of inertia is less and use that minimum moment of inertia for finding the crippling load.